Today I'm going to show you how to build a voice-controlled home automation system using these three simple devices. The first one is a universal device ISY unit, which controls devices that are connected to either an Insteon network, an X10 network, and I believe there's a few other products that Universal Devices works with. I'm only familiar with X10 and Insteon, so that's what I'm going to use for this demo. The device in the middle is really the heart of the system, and this is what's known as a Raspberry-pi. It is essentially a mini computer. Well, I'll take the bet it's not a mini computer. It's actually a full-size computer, just about the size of a credit card. It has everything you need to get started. It's got a power supply, and I'm not sure if you can see that slot right there, but that slot is where you put in the SD card, which becomes your hard drive. It's got audio ports. It's got two USB ports and an Ethernet port. So we're going to install some software there as soon as the Jasper project, and we're going to use that to control our ISY device. The third device we have here is a Jabra 410 USB speakerphone, and we'll plug this into the Raspberry Pi along with a Wi-Fi dongle, so you can pretty much situate this anywhere in your house you want to do voice control. Since a lot of you probably don't care about how this is put together and just want to see the final results, I'm going to put this at the beginning of the video instead of the end. So what we have here is the completed Jasper Raspberry Pi assembled. It's pretty much just consists of the Raspberry Pi unit right here, which has a Wi-Fi dongle up top, and the USB speakerphone. So, and also the power supply. So you can situate this anywhere in your house. You've got a power supply, and you should be able to send voice commands to this unit, which will then activate your ISY device to turn on or off certain scenes or devices in your house. And up here I've got running the console application, which is showing you the output from Jasper right now. I actually have the microphone muted so Jasper won't pick up, because every time you say the word Jasper, it starts listening for commands. So that being said, I'm going to unmute Jasper, and we'll go ahead and start issuing some commands. Jasper. Time.
It is 11:10 a.m. right now.
Jasper. Den.
On.
Jasper. Helicopter. Jasper. Weather.
Today, the weather will be overcast in the morning, and partly cloudy. Foggy. High of 73 Fahrenheit. Winds from the south at 5 to 10 miles per hour.
Jasper. Den. Step 1. You need to download the Jasper image and then burn it to an SD card. When you download the Jasper image, it will be in a zipped tarball format, so you'll have to use a utility like 7-zip to extract the IMG file from it. Once you have the IMG file, use an imaging program like Win32 Disk Imager to burn it to your SD card. And it's as simple as just putting in the name of the image file, selecting your device, and hitting write. Do confirmation, and away we go. So this takes about 10 to 15 minutes depending on the speed of your computer. So I'll speed this video up, and I'll see you on the flip side. Okay, we're done. So we just have to click OK, and then we can exit the disk imaging program. So now let's connect everything to your Raspberry Pi and get it started. First, plug in your SD card, and then you want to make sure that you have your USB speakerphone plugged in. In addition, you also want to have your Wi-Fi dongle plugged in. Then make sure that your Ethernet cable is connected and that is plugged into your network. The very last thing you want to do is to plug the power in and boot up your Raspberry Pi unit. Before we can remote into your Raspberry Pi unit, we need to know the IP address. Generally, you can find this out by visiting your router and finding the attached clients and looking at the IP addresses. What I use for my implementation is I use the Tomato router firmware, and I assign a specific IP address to each MAC address. So I always know that when I boot up with my Raspberry Pi unit, my LAN Ethernet is going to be a specific IP address. And I've actually set up a host name for that. So if I go ahead and ping PI LAN, which is the host name I gave it, I will always get 192.168.161. And the same thing holds true for PI, which is the Wi-Fi dongle, which points to 60. But since that's not connected right now, we're not getting any responses. So that's how I know where my IP addresses are. How you want to set it up is up to you, but most likely you'll need to visit your router to find out what IP addresses are being assigned. Now that we know the IP address, we can go ahead and use your favorite SSH terminal to connect to the Raspberry Pi. I'm happy to be using MOBA Xterm, but you could use whatever you prefer. So let's go ahead and go to MOBA Xterm, and we'll issue the connect command, which is SSH. And you put the username at the address, in this case it's PI LAN, and that should be enough. If it asks for a username password, you can use pi/raspberry as indicated on the instructions here. Okay, so the first command we want to issue is the command to expand the SD card so everything's available for use for the disk space. So I'm going to copy this command and go back to my terminal and paste it in with Control-Shift-Insert and hit Enter. And I'll select option 1 to expand file system. It does some stuff behind the scene. It says it's resized everything. We need to reboot. We'll hit OK. And tap over to Finish and hit OK and say yes to reboot. And now the system goes down for a reboot and it kicks us out. And if we go back to our terminal session I have left open, and I tend to leave this open a lot while I'm setting this up, and I ping PI LAN, you'll notice that we're not getting any responses. So usually what I do is I keep pinging this until I see a response, and at that point I know I'm able to connect back into the Raspberry Pi unit. So I'll let this time out until it actually connects, and then we'll start up again. Okay, we've waited about 30 seconds, so let's go ahead and try to ping it again. And you'll see we're getting a ping, so we should be able to remote back into it. So let's go ahead and go back to MOBA Xterm and try connecting again. And perfect, we're logged in. So now we can move on to the next step, which is setting up your Wi-Fi dongle. So let's just go down here, and the first thing we want to do is modify your network interfaces. So I'll copy this command line, which opens up a text editor in Linux, and I'll paste this in, and brings us to the default settings. But what we're going to do is going to replace everything. So let's go back and copy this, and I'll hit copy. And first I want to delete all the lines here, and using this editor you can just press Control K. That deletes each line. Once everything's deleted, I'll do a Control-Shift-Insert and paste that in here. And here you're obviously going to want to put in your network SSID and your network password. Word to the wise, your SSID is case sensitive, so make sure you get that entered in correctly. If you don't, it won't connect. So after you're done, you go ahead and hit Control X to exit, hit Y, yes to save, and return. And you've configured your Wi-Fi dongle. The next time you reboot, both your Wi-Fi and your Ethernet should be enabled, so you can connect to either one that you prefer. When I'm doing setup, I usually prefer to connect to the Ethernet because it's slightly faster. But after I've already set up the device and I want to plug it in somewhere like my living room, I'll use the Wi-Fi because I don't necessarily have an Ethernet cable where I want to locate the speakerphone. So let's grab the Jasper source code, which is specifically designed to work with the ISY unit. So let's copy this value from step 5 here And let's go ahead and paste it back into our terminal. And what this does is this downloads some code from GitHub, and specifically the branch that I wrote for the ISY unit. And then I have to press enter here manually for some reason, so you will too. This will actually prevent the Jasper unit from trying to boot. We want to disable that until we get it working properly. Okay, so now that we've done that, let's go to step 6, and let's go ahead and run the script, which will update the actual Raspberry-Pi OS on the system. Let's paste that in there and hit enter. And this will take a few minutes, so I will let this go and speed up the video. Alright, that took about 12 minutes, so let's connect back to the Raspberry Pi. It looks like it rebooted automatically, so let's telnet back into it, or SSH back into it. And let's move on to the next step, which is step 7, updating the firmware. So we'll copy this code and paste it in. And this only takes about 3 minutes, so see you then. So now we need to log back into the Raspberry Pi unit. So we can run the same command again, sshpi-pi-lan. And let's get the next step, which is to install the USB audio script. So let's copy that from step 8. And let's paste that in here. And what this does is it changes some settings to make the USB a preferred speaker in the system. And we also have to press enter here to force a reboot. I'm not going to speed this video up because I'll have to wait for it to reboot. And I'll give you an idea of how long it takes for the delay for rebooting. It takes about 15 to 30 seconds. And the way I usually determine if it's ready again is I just keep pinging on the terminal until I start getting responses. Do the -T option. There we go. We have a response already. So I can stop this and go back here, and we can move on to step 9 now, which is to actually test the level of the USB speakers. Before we do that, we want to run this ALS mixer program, which shows us our USB audio equipment. So first we actually have to connect again, so we have to log back in. And now I'm going to run the ALS mixer that I just copied. And we see the volume level for our speakers, which is about, I don't know, 20%. I'm going to make it about 55%. And let's go over to our capture device. I'm going to press F4, and we'll see that the microphone's at 0, so that's no good. So let's go ahead and move that up to about, I don't know, 70%. And we'll hit escape to get out of there. That should save the values. Now let's go back and run an audio test script. So this script should record 3 seconds of audio from our USB speakerphone and then play it back for us so we can tell if it's working or not. So I'll paste that in here. It'll give us a message to speak in the microphone for 3 seconds and press enter to begin. I'm going to bring my speakerphone closer to this microphone so you can hear it. So I'll press enter. This is a test. This is a test. And if you heard that, you could tell that the audio in the speakerphone is working properly. The next thing we want to do is install the prerequisites for Jasper. So let's go back and copy that script, which is in section 10. Copy this and paste it back in. And this takes several minutes to run, so I will see you in a few minutes. So So now we're finished. The only thing we have left to do is to configure Jasper to point to our ISY unit and to what devices we want it to control. So let's go back and look at our Jasper config file, which is in the Jasper directory. And it's called jasper.conf. So I'm going to use the nano editor. And let's look at some of the values we have here. The first is the location profile, which just uses your US zip code. So I just put 90210. For the time zone, US/Eastern. You can get these values from Wikipedia. And if you look at the documentation, I believe it explains how you can figure out what your time zone value is. This isn't really necessary. This is only if you want to use the time and weather modules that are built into Jasper. I'm still on the fence whether or not I'm going to leave them in. I think they're kind of useless, but they're cute. I have disabled most of the other Jasper modules that like ones that read news to you and check your email, because I found those completely useless. But that's just my personal preference. The audio section, you're not going to really need to do much here. If you're using a USB speakerphone, the script should have set it for you as 0,0. Otherwise, if you're using a plug, using the microphone jack, it would leave this plug HW1,0. It has the volume set for 25%. I'm going to make that 55%. The microphone 90%, and we don't want to mute either of the speaker or microphone. If you wanted those muted by default, you could put it on here, but that's not necessary. So let's move down to the ISY section, and this is where we would put in the IP address of your ISY device. And that's just what happens to mine is pointed to. And of course, you replace that with username and password that you can access the ISY device. Now let's jump down here to the devices section, and here's where it really gets interesting. So I've defined 6 devices here. I've got den, fan, stairs, bedroom, kitchen, and family room. And most of them have 2 values separated by a comma. The first number represents a scene, and this is a scene as defined by ISY. So even though I've got one thing here called fan, a fan still has a scene. Most of my devices, even one-to-one mappings, I always have an individual scene per device, and this is just for consistency's sake. So whenever I say send a command where I want to toggle the lights in my den on and off, I will issue this scene to be sent to the ISY unit. And then the second value, when there is a second value, represents the node, which is kind of the master of the device. So for example, if my den scene consisted of turning on 3 lights and the ceiling fan, I might consider the overhead lights in my den to be the master device, and this would represent that device. And the whole purpose of this is, if I issue a command called toggle, it will look at this master device value to see if it's on or off before deciding whether or not to issue an on execution command to the den or an off execution command. Same holds true for the other devices here, for the fan, for turning off the stairs. This bedtime scene, there's really no on or off. I just want it to execute on all the time, so I don't need to include a master device. And the same things for the family room. So here are the various scenes that I have set up. And now that I've got these set up, let's go ahead and test a couple of them. So now we just need to set up some modules to listen for specific words to fire off certain scenes. So let's go to our client modules directory. And let's see what files we have here. So we already have one called fan, so let's take a look at that. So right now it's listening for the word helicopter. And why did I choose the word helicopter? I think it's because I was having some issues with fan interfering with some other words. I wanted something really simple, easy to remember, so I just chose helicopter. So let's just leave that for now. So whenever it hears the word helicopter, and you can also add additional words here, it will fire this off if the word helicopter also matches the search phrase, which is a regular expression. So if you're looking to just do one-word phrases like helicopter or fan, you basically need to put that word in here at the bottom and here at the top in the word section. And then inside of the handle event, we call this toggle function, and we're actually calling fan, which is the value that we specified in the device file. So this one should work right now for the fan right away, but let's go ahead and set one up for the den lights. So let's copy fan, and we'll copy that to call it to den.py. And let's go ahead and change the word helicopter to den. I don't know if you need to have this case sensitive, but I always make it that way. And right here, by the way, notice we call the command toggle. If we wanted to actually turn it on or force it to an on state, we could have done something like this. Result equals ISY dot command, because that's one of the functions there is actually issue command. It's a two-part command, so either den, and it would have said turn it on, or you could have said turn it off. But let's go ahead and just leave it for toggle right now. So let's delete that line and we'll save this.